Today we're going to be making some 4-point surfaces, and we are going to be simplifying those into planar surfaces. So 4-point surfaces, if you think about it, what type of object could have 4 points? A square, like a square surface, right? And so for example, this one has 4 points, right? But if I were to move this point out of its plane, what would it have to do? It would twist, right? So it's very easy to draw twisted surfaces in a NURBS package. It's then the trouble is actually then trying to get those back into planar surfaces. Does anyone have an idea of some like typical shapes that will always be planar? Like how many sides does something need to be a shape? Like a closed shape. Straight sides. 3, right? So triangles. So as long as you've got 3 points and you connect them with straight lines, you'll always have a planar shape. You can't be guaranteed that with any other sided shape. So if you have 4 points connected with lines, then there's no guarantee it's going to be planar. Okay? So what we're going to be doing today, you don't need to follow, I'm just going to demonstrate the shape that we'll be making, is creating a script that generates a 4-point surface. So one that is made up of 4 points, like so. But it is going to be taking those 4 points and shifting them in 3D so that we end up with a double curved surface, a hyperbolic paraboloid. Okay? So if I were to take 2 points of a square and shift them in 3D, we get a hyperbolic paraboloid. Then we are going to break this down into 4 surfaces. And we are also going to design this so that it can be rotated radially. And I've just done this a super easy way for myself with only 4, but the script will be designed so that we can work with multiple. So we could have 7 or 10 or 1,000. But the point being that they'll be radially rotated around a center point. Cool? Okay, so if we were to just look at this shape right now and begin to pseudocode it, it might be easier to look at it with 6. Is everyone familiar with the term pseudocode? It means fake code, right? Or like before code. So prior to a lot of exercises that software engineers take at uni is to actually just create a flow chart of what their particular script is going to do, and that's exactly how we're going to work. And I like to use a metaphorical character called 2 Brain Cell Man, because he's a dumb idiot, because that's what your computer is. It's stupid, okay? It actually doesn't understand things very well. If I were to tell a robot, if a robot actually understood words, right, and you could tell it to go do something, but it didn't have any connection to like processors, and you said, go bake a cake, it can't do that, right? You have to give it every instruction. Go to the cupboard, open the cupboard, pull out the flour, grab a sift, pour the flour into the sift. If your instructions are wrong, then it didn't grab a bowl and now it's pouring flour onto the floor, okay? That's exactly what we're doing with geometry in Grasshopper. So every word that you say is important, semantics are important. So moving something is different to offsetting. Rotating something is different to orienting. So just be mindful of that, okay? So I'm going to be really semantic when I do to brain cell map, okay? So when I ask you guys to give me instructions, what you say I'm going to do to the letter. Cool? So pseudocode. I'm going to start you guys off. First things first, we're going to be looking at a point as a center point, because we can see that this is radially symmetrical. So it would be good to start setting off a radial point, okay? Then, can anyone see a relationship between any of the aspects of this design? Like, for example, the outer points, are they the same distance away from the center point? So what could they exist on?
Single plane.
They could exist on a single plane. Is there any other geometry that they could exist on? For example, if I were to draw them, so here's a point, is there any other geometry that they could travel through? Pardon? That's also true, but what if there were 6? Huh? Yeah, a cylinder, so a circle, okay? So if I were to draw a circle, then those outer points are always going to sit on that circle, yeah? And can we say anything about these inner points? It's sort of maybe worth me doing this, just to help define this a bit more. Oop. Whoa, that's loud. Hello. Have you checked if there is space in the other room? Ah, you're leaving. Okay, so we've got these outer points. There's more geometry. See the concave joints, could they exist on any form of geometry? Another circle? Yeah? So if I have 2 circles, right, I can create my diamond off those 2 circles, yeah? Can everyone see that? So if I draw a circle and a second circle, we have all those points sit on some geometry, okay? So we can basically say that those 2 circles could actually be our guidelines for the design. So instead of sort of defining one single object, we can define the whole geometry that defines the whole object. Okay, so if I've got 2 circles and a center point, so the center point will always kind of define those 2 circles. That's the one problem with these rooms. I don't have the erasers, and I really don't want to use my jacket. My wife's going to kill me if I use this. Oh well. You know what happened if I'm not here next week, okay? So we have 2 circles. Now let's just step through the process, okay? Someone here, anyone, those of you in the back, can you try and move forward, try and move the table forward? Because I want everyone to be able to see. So if you can move the table forward, please do. Okay, so this is a conversation. I really don't like people not saying things in the class, okay? I'm okay with people getting the answers wrong, okay? So please say something instead of nothing, Cool? Let's stab at what one of the steps would be to start getting this shape, okay? What do we need to do?
We need to start a focal point for the concentric circle.
Yep, which is what we've done.
And then when you have to set on the vertical axis some different height between them because the shape of the hyperbolic.
So let's think in 2D for now. Okay, so we're thinking in 2D. Just ignore the fact that I've done this in 3D. I want to draw a diamond from this circle, okay? How do I draw a line? How do you guys draw lines? You connect 2 points. That's one way of drawing lines, and that is the way that we're going to use today. So if I draw a line, I'm subconsciously connecting 2 points, okay? The computer needs to know where those 2 points are. So,
Split the circle into 4 even points.
Okay, which circle?
The inner one.
Okay, split the circle into 4 even points. Someone else, what's the next step? I've got a point in the middle, and I've got points on the circle. Connect the lines, connect the points. Which points? They're all drawn.
From the center.
From the center. Right. Next step. Okay. Really? Okay. So we've shifted them 45 degrees, okay? So they've rotated. Now, there's a problem here, okay? What if we want to do 6? Or 1,000? What's the degrees that you need to rotate? It's difficult, right? Now, I know we're using a computer and computers can work out what 360 divided by 1,000 is, yeah? But sometimes it's good for us to think in ways that we don't have to do those calculations. So, oh, that's right. You're right though. We need an alternating pattern.
You then divide the outer circle by 8 points.
Yep. Oh, what am I doing? Yeah, which is what I've done. So you divide by 8 points, then what?
And then connect the points from the inner circle to the point on the outer circle.
Okay. Okay, if I do that, I get this. Sorry. Like, do we know which points we want to connect to? Let's just redo this, just because it's getting a bit confusing. So, if I have 8 points on the outer circle, is there any way that you can tell me which ones to use? So let's think about this. Every item could have an address or a number, okay? So I could say that this whole class is a list of people, which you are, including the person hiding under the table, okay? And I'm gonna, even though I don't know your name, I can say that you're student 0. Okay, and you're student 1, you're student 2, and you're student 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay?
Is it to be connected along the shortest distance of the inner circle?
No. Exactly, it's that easy, okay? Just use all the odd numbers, okay? So if this is item 0, 1, 2, 3, you're right though, you can be right, but the reason I'm saying no is because you're not sure about what's going to happen in the future when things might change in 3D. So, but this is a really robust way to do it. So when you have 6, 7, when you have these numbers, I can now say grab all the odd numbers. So we'll grab these ones. Right? So if we've only got the odd numbers, then when we connect these, so now if I were to think of these as numbers, 0, 1, 2, and 3, if we pick these out, what item does this become? If I've got a list of only the odd numbers, what does the first odd number become in a list? Okay, so think of this. I've got a class of 15 students, or 16, so from 0 to 15, and I pick out 3, 4, and 5 as a separate list. What item number is the first student? Right, 0. You always start at 0, okay? 0 is always first. So if I've picked these out, what do they become? 0, 1, 2, and 3. Okay, so what do we see? We want to connect 0 and 0. And then we want to connect 1 and 1. And 2 and 2. 3 and 3. Okay? We're not done yet though. Hang on, I'll just do our little thing. What else do we have to do? It's almost complete.
Join 1 to 0.
Yeah, okay. So there's one way of doing that. And the reason why I've drawn a circle, the reason why I love this particular example for this is because it's a circle, okay? Even though when we think of lists, we think of them as a linear thing. So in Grasshopper, if I draw a list, we think of lists as linear. Okay, and there's going to be a few different geometry metaphors that I'm going to use for lists throughout the whole semester. But in this case, we're going to, I'll just pull up a series. So this component just creates a list of numbers. So we usually think of lists as stacked on top of each other like an Excel table, basically, right? But we can also think of lists as circles. So item 0 of a list is always first, and I'm going to remind you guys of that constantly because it's one of the most important things. 0 is always first. So what if I had an 8 length list, like what I've got up here, 8 length, what is the last index? 7, okay. Now, if I, this is gonna hurt. There we go. I should go do that the other way in the future. So if I have 0, 1, 2, 3, we'll just leave it at 3 for now, so 4 items. So the last index is 3, yeah? So if I were to represent a list like so, 0, 1, 2, 3, if I go one more than 3, what do I get? 4? 4? If I go one less than 0, what do I get? What's 0 minus 1? Negative 1. Okay. So if I say pick out -1, where do I go on the circle? If going this way on a list if going sequentially up is going clockwise, then what do I get when I go backwards? I go anti-clockwise. So what's -1? it's the last item, 3. Yeah? So if I have a list that's 1,000 long, then the last item is always -1. And the first item is always 0. Okay? So if I were to say shift a list, so I'm going to want everything to move forward 1 or backwards 1, then we can consider these lists as these radial objects. So item 0, the index of item 0 will shift 1 to number 1. Therefore, that becoming 1, I mean 0, 1, 2, and 3. Okay? So if I do something to this list, what could I do to make 1 connect with 0? Shift it in a negative direction. So shift it by -1, yeah? Like so, making this 1, and this 0, and this 2, and this 3. Therefore, 1 will now connect to where?
0.
No.
Oh, 1.
Right. And we get that. Okay? I know it's getting a bit confusing, so let's do it. Let's actually script it. Okay? So those, I'm going to repeat all the little sort of like basic stuff that we did last week. So Grasshopper is a dreamscape. It's a baking mix. So I'm going to completely explain it again, just so that everyone, does even those people from last week want me to re-explain it? Okay. So if you draw something in Rhino, or any CAD package normally, you can pick that object, you can move it around, you can work with it. But it's a static object. Grasshopper, we have to think of it as kind of like another universe, and think of it like the upside down from Stranger Things. Everyone seen that, right? Pretty much. Okay, cool. So it's like it's a place, it's a dream space where we can do really creative things, really dynamic things, but when we do work in there, we can't actually touch it physically in the Rhino world, okay? It's just Grasshopper geometry. And there are we need to basically force Grasshopper to take geometry in from Rhino. We have to tell it exactly which geometry we want it to take in, and that becomes sort of like a bridge between the two environments. And then when we're finished, we have to bake the geometry. And I like to make the metaphor of baking a cake. So if you have a cake mix, you can pour cake mix into any shaped tin, and we can, if we're not happy with that tin, we can unpour it and pour it into something else. We can add things. We might be able to take things away. But the instant you put it in the oven, it solidifies and it becomes a cake. And if you want to suddenly change the shape of the cake, you can't really make it go back to its cake mix and pour it into another tin, okay? So Grasshopper is kind of like this fluid environment that sits in this dreamscape, and there are ways that we need to get information in, and when we pull information out back into Rhino, it's static, okay? So that it dissociates itself from that Rhino, the Grasshopper script. Those of you who aren't using a computer, is there a reason why you just don't have one, or do you have a computer? I would suggest do you have Rhino? Go get Rhino. Do you have Rhino? It's free for the first 90 days. There's a website to download it. I suggest you go get it. You're going to need it. And it's worth following along. I'm recording this, but it's much easier following along because you're going to give me confused faces and I'm going to stop and repeat myself. Yeah?
Just to recap what you just said. So what you just did with creating was it 4-pointed?
Yep.
Hyperbolic parabola.
Yep.
That's all been scripted in.
We are going to script it.
Oh, okay.
We are going to
So
script
it
that.
doesn't automatically write that up
No. If you could just draw things and it literally watches you and copies you, then I'd be out of a job. Which is one day will happen, and I'll have a lot of fun just designing things without actually having to think. So those, are you guys on Mac or Windows? Those the two of you that are. They're on Mac, so you have to get Rhino 5 for Mac. Cool. Okay. Okay. So step one, I honestly prefer drawing control points in Rhino and referencing them into Grasshopper. You can draw your own. You can create points directly in Grasshopper, and I'll use both methods here, and you can choose which one you want to use. So if we go to the point parameter, the parameter tab, we can get points as a parameter. Or if you go to vector tab, we can get construct point, which will basically take an x, y, and z value, which is the Cartesian coordinates. Everyone here is familiar with year 10 geometry. Yeah, good, I don't have to explain that stuff. Good, excellent. Okay, so if we draw a point in space in Rhino, and we right-click our empty point parameter in Grasshopper and select set one point, we can pick that point, and that point should now be green or red in the Rhino environment, showing us that Grasshopper has it. Can everyone see, by the way? I just need to make sure that none of the components are sort of sitting here, right? It's just hard to see them here. Okay, cool. Or with the construct point, we can create number sliders. So they can be grabbed under the the parameter tab under input, and we have number slider. Okay, that's not a stupid question. Under display, there is a button called draw icons. No stupid questions. There's only stupid answers. And they usually come out of my mouth. Cool, so everyone knows draw icons now? Cool, so we can get number sliders. A few other ways really quickly for those who weren't here last week. If you double click, you can create number sliders by just typing a number in. So for example, if I type 10, or no, let's say 9, then that will create a number slider that is integers. Or if we've got a number slider out already, we can double click it and change the minimum and maximum, whether or not it's integers, even or odd, etc., etc. We'll get into that a bit later. We just basically need to start scripting. So I'm going to use the point, and I'm hoping you guys are using that too. When would we need that? Okay, I know when. So, what do we, if we were to define the minimum amount of information we need to draw a circle, what do we need? Okay, we need radius, and what else? Yeah, center point. That's one way you can draw a circle, okay? So if I go to the curve tab and under primitive, we can see all the different primitive shapes, be they lines, circles, arcs, polygons, rectangles, etc., etc. And we can see circle. And even just highlighting circle will tell me, I'll read it out, create a circle defined by a base plane and a radius. So the fact that we're working in 2D right now, we're ignoring the fact that a point could technically be defined as a plane. But yeah, it's this circle here needs a point and a radius, so we're going to create a number slider for that. So if I just double click and type, let's say this thing can get up to about 30 millimeters. So if I say 0 is less than 30, that'll create a number slider that goes from 0 to 30. Okay, so double click, 0 less than, or if I go 6 is less than 8, then that'll create a number slider that goes between 6 and 8. Okay? I swear this university has the most construction. Like every tutorial lecture I've got some person above me, below me, on the side drilling something, like constantly. Yes?
It is like double click the circle one, but I haven't tested it out.
Don't double click the circle, double click the canvas. Okay? And we can drag a wire into that radius. So we can now see as we slide that up and down, we're dynamically changing the radius of our circle.
When you type 0 to 0 is make a slider of 0 to 30.
Yeah, I'll type what that is in here, and I'll make that massive. Yeah, go on.
Is it by default in millimeters?
No. No. That is a really good point, actually. Let's make this bold. Let's make this... Is it going to let me pick a font? Maybe not. There we go. Is that easy to read? Okay, so that's what I've typed. So Grasshopper doesn't give shit about dimensions. It doesn't care what units you're using. What it does is relies on Rhino to define that. So in Rhino, my file is set to millimeters currently, and when you open up your file, some of you may have defined millimeters or centimeters or meters, depending on who you are. I'm sure a lot of the landscape architects, do we have any landscape architects? Okay, they're in the other room. They're probably picking meters. All the architects and industrial designers are picking, and basically everyone else is picking millimeters, right? Okay, cool. Any urban planners? Or project managers? Do you normally think in meters? Mil. Okay, excellent. So when we start the file, we can define that, but under mils, we can actually right-click that, select unit settings, and then we can pick whatever we want. We can even pick parsecs for those of us who like Star Wars. So there's that it works to whatever you're working in Rhino. Cool. Okay, so we've drawn a circle. Now we need a second circle. There is going to be something that is very specific about what we're going to do, though. In our really messy diagram on the board, what is the only difference between the two circles? Okay, and what is that difference? What is that radial difference? It's larger, correct. So if I did it the wrong way. Ooh, shit. If I defined one circle as larger than the other, like the opposite, right? We're going to end up with a shape that looks like this. Does that make sense? So, one of the circles always has to be larger than the other, okay? And we can do that a few ways. If I took the number 30 and I added 30 to it, and I always add a positive number, it'll always be bigger. Yeah? So, if we create a relational, an additional relation to this number, we should be good, as long as it's positive, yeah? So we can basically make this script, make sure that we don't create something shit, yeah? Cool? So, under maths, there are two ways of adding numbers. Actually, there's about 10, but the plain and simple way is by using the addition component. But I rarely use addition components. My go-to is the expression because the expression can do any mathematical function while addition can only do adding. So if I quickly copy this slider, now there's a few ways of copying. If I copy by hitting Control C and then paste, Control V, that'll just paste the number slider off on a slight slant, or I can paste it to center by hitting Control Shift V to just help clean that up. So if I add 30 to 30 and I use a panel, which I'm grabbing from parameters and input, input and use panel. So you can get panels here. Can you guys see where you get panels? Am I going too fast? Yeah? Okay. Okay, I'll slow down. So addition, we can find any maths function under the maths tab. And we're going to find addition as an operator. By the way, guys, if I'm going too fast and I don't recognize that I'm going too fast, just tell me, okay? I'm okay being interrupted. Okay, and then in there's addition. Otherwise, I'm getting expression from script expression, which is here. Yeah. How do I bake? Why? We'll get to that soon. Okay. You want to bake and then move the move the circle?
Just want to copy.
Huh?
I just want to copy.
Copy what?
Like like rectangle.
You want to copy the circle?
No, just I want to know how to bake.
Okay. If you select the circle and you middle click, there is an egg. Click the egg. It's now baked the circle. But just remember, when you bake cake, it's now cake, right? It's no longer cake mix. So if I change this slider, see how we leave behind the cake? The cake's now left behind. Yeah. So just baking is the last thing you need to do, basically. Okay, is everyone really at this point? We've got two sliders. We've copied one slider. And we've connected them to an addition component. Yeah? No? Where are you at?
Still working on making a point.
Pardon?
Still working on making a point.
Okay, let's go back to making points then. Yeah. Okay. So just to re-explain, we've got the parameter tab. The params tab has two different types of parameters. There are geometry parameters and primitive parameters. Generally, geometry parameters are anything that is physically drawn in Rhino, or can be drawn in Rhino. And primitives are usually things that are beyond geometry. So a number is like a metaphysical thing. It's a number, or a color. So in this case, we want to grab a point. That's usually it's the first one in the list. If we click and plop that into the canvas, you've got that. Then if we want to pull geometry into Grasshopper, we select and right click our component, and we can either pick set one point or set multiple. If we just choose set one point, we can pick that point, and that then pulls that into that component. Now, sorry, I'm kind of skipping over that quite quickly because we did cover it last week. Sorry about that. That means that we've now got that referenced point collected into that parameter. Is everyone else at least at that point? Pardon the pun? Okay, cool. Then, have you got the circle?
No.
Okay, so you can find circles under curve. And you've got this circle component here. Under primitives, you got circle. And do you have a number slider? Okay, So just to remind everyone, number sliders can be found under the params tab in input. It's the first one there. Or we can also double click and type a number. And if we want to define the minimum and the maximum, we can type the minimum number less than the maximum number, and that'll create a number slider between those two. Is that cemented in everyone's mind? Everyone's at this point now? Do you have a number slider?
No. Why is there a 3 point versus a...
Pardon?
You got your circle has P, R, and C.
It has P and R and C, yeah? Yeah?
No, I picked a 3 point.
Okay, that's because circles can be defined other ways. Okay, so that's the way the way that you've chosen is the way that you define a circle from 3 points. Okay, we want just circle. Can you see that one? Huh?
Yeah.
Excellent. Yes.
Yeah, it's one question like how to delete and
How to delete?
yeah.
Select the component and delete it. Press delete.
Oh, yeah. That, but
Press delete on the Mac. It's not working? Try command delete. Backspace? Try backspace. If you go edit, see there's a delete. You'll see delete in the edit list. That'll tell you the command next to it, the button that you need to press. Can you see?
delete, yeah, maybe just my buttons are not working.
Well, if your button's not working, you can at least go to that and press delete. I know it's slow, but that saves, yeah. Even if your keyboard doesn't work, you can still delete stuff. Cool? Excellent. Okay, so now you need to know where to get additions.
Is that on the operator?
Have you got your number slider?
No.
Okay, double click, and you can type 0 less than 30, and that'll give you a number slider.
Yeah.
Cool. I'm going to drag the number sliders in as inputs into the circle, and now you should be able to control your circle like so.
Oh, yeah.
Yeah, cool. Okay, addition. We can get addition from the maths section.
In operators?
Yep, under operators, it should be the first one.
Yep.
Cool. Now, if you can copy and paste, so Control C, Control V, the number slider, then we'll plug that into the second, the B factor of the addition. And we can get panels by going to params and going to the input. It's that little yellow squiggle. When I hold this button, can everyone make out the circle that it's picking out? Yep. Even those in the back? Okay. Shy back row. You're all second years at least, right? Okay. The first years, they sit there like stunned like fish. Okay, we good? Okay, so panels show us information. We can also use them to input information, but they're really useful for showing us. So if we plug our result of our addition into the panel, what do we get? 26 plus 30 is 56, okay? So if I now copy my circle, and now instead of using the first slider as its radius, I use the result of the addition as its radius. There's not enough time to explain expression. I'll do that another day. Then, as we slide the first variable up and down, that changes the size of our first circle. And then the second variable then changes the radius of our second circle. And the second circle will always be bigger than the first circle. Does that make sense? Okay, so we've now created a parametric relationship. If we change if we pick our point up and we move it in Rhino, then it constantly redraws those circles, wherever we move that point to. Cool? Excellent. So, we've got two circles, we've got a point. We're basically at the beginning of this pseudocode. It took a while, but we're here, okay? So, what did we do Can you remember?
You pick points on the inner circle.
Yes, how many points did we pick? We picked 4 points, okay? So we needed, is there another way of describing that?
Equidistant. Along the diagonal.
If I were to give you a line and ask you to break it up, what's another word to describe that? To divide the curve. There's no wrong answer, you're right. You can quadrant it, but then you only get 4, right? So just to remind everyone about how to navigate your way around Grasshopper, if I wanted to divide a curve, where would you look? Which area of Grasshopper would you look for the divide curve component? Huh? No. What are we working with? We're working with a curve. Can you see curve in the ribbon at all? Okay, now when you get to curve, have a look in curve. What do you see? There are sections. And the first one's analysis. The second one is division. So you're probably going to find something that divides curves in that. And in division, there's the plain and simple divide curve. Let's use that. Okay? So, guys, if I wanted to measure the area of a if I want to measure the area of a sphere, spheres are surfaces. So which tab do you reckon you'd find that component? Right. Okay, if I want to find where two lines touch each other, which tab do you think that will be in? Intersect, okay? So everything, your whole entire Grasshopper world has been categorized and sorted in a nice human readable format, which is the ribbon. Just get used to it and explore it, and be mindful that if you don't know a component, it's probably there. You just need to go find it, okay? So, dividing curves. Dividing curves require 3 inputs, and we can ignore one of them. It requires a curve and a number, a count. So, if we plug our circle into divide curve, it immediately divides it by 10. And we're going to create a number slider. And we'll put in, I'm going to put in the numbers 0 to 20. If I can actually type it properly. 0 is less than 20. That's better. And if I plug that in, we can't divide by 0, but we can divide by any other number, as long as it's an integer. And as we run that up and down, we get a dynamic set of points. Okay. Now, we're going to do the exact same thing on our second circle. So we're going to copy the divide curve, and we're going to plug our second circle in. Now, do you notice how I've used the same slider, the same number slider for the count for both? What that means is that now shares that variable. So these two things are now inherently linked with that variable. As I slide one up and down, they both change, okay? So what we're going to do is we're going to use this number slider to define the number of segments we're going to have, okay? But we know, as we noted in the pseudocode, on the outer circle, we generated more than what we needed, yeah? So if we need 4 panels, how many points do we need to generate? 8, okay. If If we want 6 panels, how many do you think we need to generate? If we want 6 panels, if we've got 4 panels, 1, 2, 3, 4, we need to generate 8 points, yeah? Because we get rid of half of them. So if we want 6 panels, 1, 2, 3, 4, 5, 6, how many points do we want on the outer circle? 12. 4, 8, 6, 12. So if we wanted 8 panels, it'd be 16, okay? So what relationship do we have there? Times 2, okay. So what operator do you think times is 2 numbers? It's very critical. It's a critical thinking class with really soft questions. Okay? So if we go to math, what do we find? Multiplication, right? So, and what do we want to multiply our number by? 2. Now, we could create a number slider, but good practice states that number sliders should be for sliding. Okay? We want to slide number sliders. We don't want to slide this number though, right? It's going to be fixed. It's always going to be 2. So there's a few ways that we can do this. We can either, what are you looking for? Multiplication, you can find it here. Huh? It's under maths. It should be in operators. It should be called multiply. Is anyone using a different language version of Rhino? You're all using English? Okay. I was just wondering if they've written grasshopper in Chinese or not. It'd be useful, wouldn't it? Okay, so we could use a number slider, but we don't want to slide this number. So sometimes you'll see people, they'll use a panel. If you drag a panel in, double click it, you can type variables in and then use those as fixed values. Or you might see me sometimes grab a primitive parameter like this one. So this one's an integer. And then I'll right click it, set integer, and type 2. But I'll use panels for now. If I slip into my normal way of doing it, the way that I shouldn't be teaching with, just let me know. Be like, Andrew, we don't know what's in there. Please make it a panel. Okay, so we're going to actually times both. We're going to use this times 2 value on both the divides because I want to show you a technique that is used on both. So that means if I've got 4, I should end up with the outcome that produces 4 panels, which is what I've got. Sorry. Oh. So everyone.
So where'd you get the integer?
Integer is under the primitive. You can get it here. I love this little shortcut. It's so good. I don't even have to see the screen. I'm like, yeah. Just click it. Okay. But I'm not using integers for now, okay? So I've got 2 sets of curves. What time is it? Okay, we've got 2 hours. Excellent. Do we? This finishes at 12, right? Yeah, we've got 2 hours. We're going to kill it. Excellent. I love small class sizes. They're great. Or classes that won't admit that they're not following. Okay, so if I just quickly go to the display tab, and you'll find under there, this is something that Christina showed you guys last week. There's this thing called a point list, and it is really the only way to visually see what indexes the points have. So what we're going to do is plug our set of points into the P, and you'll probably note that it does nothing. If I zoom in, like as close as I can, it's impossible for me to see what it actually does. And that's because when this is set to 0, effectively, the text outcome is going to be screen sized. So if I hide my points, so for those of you who missed this last week, we can hide components by selecting them, middle clicking and selecting the little dude with the blindfold. Or if your middle click doesn't even work, then you can right click the canvas and then select preview off. And can you guys make out these tiny little numbers? They're tiny. Can you see them? You can't see them? Okay, well let's make them bigger, okay? So if we mouse over the S, that says size, right? So we should be able to plug a slider into the size. So I'm gonna just grab a slider. We can generate the slider any way you want, but just make sure it's more than the like we want this to be more than 1, so we'll go 10. We'll plug the slider into the S, and now as we slide that up and down, we can make our numbers really big. Okay, so what do we see? I'm seeing faces like, wow, that was too fast. Okay, so do you have point list? No, you don't. Do you know where to get it? You do now? Good. So is most of this class architects? We've got some interior designers. Cool.
What tab is that on right now?
It's under the display tab. And there's a little, you can see there's a little funny sawtooth pattern at the end, like on the right-hand side of this point list. And that's because there's, it has no output. Like you can't use anything from it in Grasshopper. It's only there to push data into Rhino, and that's it, okay? Excellent, so we can play with this is just for convenience more than anything. Okay, so we can see that we've got 7 numbers from 0 to 7. And what's one difference about these numbers than what I drew? And any other difference? This is this is really important for computers, okay? They're going anti-clockwise, okay? So computers and geometry always want to go anti-clockwise. So if you draw a shape like so, anti-clockwise, if I offset, the positive offset's going to go out. And if I draw it clockwise, my positive offset will go in. So it's generally best practice to think of things anti-clockwise, but sometimes it doesn't matter, okay? Sometimes. Generally though, when you draw a circle, in the plane that it's in, that it'll be anti-clockwise, and everything that you generate will be anti-clockwise, so it's good to consider that. Yes?
How did you get yours to display up to 7?
What did yours display?
Mine's only 1 to 3.
1 to 3? Okay, how many points are you generating? What number do you have in this slider?
4.
Really? Are you timesing that by 2?
Yeah.
And are you plugging the outcome into the n value?
Yes.
And it's only generating 4 values. Are you sure? Okay. Be the first time that 4 times 2 and equals 4.
Not sure which real.
What's in that integer?
So I set the value.
Oh, dude, look.
Yeah.
Just look at what you've done versus what I've done. How many components does this plug into? Okay guys, this is where my little troubleshooting thing works really well, okay? Everyone, select your multiplication component, hold Control Shift, and then press, or Command Shift for the people who really like to look cool. And then press right. How many components have I selected now? So what that does is it selects upstream. So it selects all the components that my multiplication is connected to. Okay? How many components does yours has 3? I have 3. And how many does yours have? 1, 2. 2. Okay, so where is my multiplication connected to? Both the divide components. And where's yours connected to? Just 1.
Oh, yeah, so.
Excellent. Troubleshooting, yeah. Okay. Is everyone good? Cool, okay, so we've got our numbers. And we need, so if we go back to this idea that we need to either use even or odd numbers, can someone please help choose which numbers we're going to pick out? Who wants to choose even or odd? Just whoever says it first, it's what it is. Odd. Okay, so we're going to use odd for the inner circle, okay? By doing this, I prove that I know what I'm doing. If you guys change things up for me, it keeps me on my toes, okay? I hate it when the teacher is just only one step ahead of the class. Because you guys will be like, oh, this isn't working, and they go, oh, too bad, I'll help you next week. We don't want that. Okay, so there is this component called dispatch. It is a very powerful component, and today we'll be using it to generate patterns. So what it does is it uses Boolean values. A Boolean value is a value that can only be one of 2 things, true or false. So, for example, I can't think of anything in reality that can actually only be true or false. 2 plus 2, the answer 4 will always be true, and every other answer will be false, right? So there's only true or false, discrete, yeah? So if I were to go through and assign a true-false value to the whole class, I can do it one way, which is the long way. I can say, you're true, okay? That doesn't mean good or bad, it just means you're true, okay? And you are false. Not good or bad, just false. True, false. True, false, true, false, true, false, true, false, true, false, true, false, true. Okay? Too quick. Was it too quick for some of you? So everyone got their thing? It took a while, right? Or I could just say, I'm going to change things up, okay? You're false and you're true. And we know the order of things, so just repeat the pattern, okay? So false, true, what are you? You're true. Then what are you? That's because you remembered what I said and then you inverted it? Clever. Okay? Okay, what if I did this? False, false, true, false. What are you? Why is that?
We got 2 false and 2.
So you're going, but you're wrapping over, right? So you're going back to false, which means what are you? No. What was the pattern? False, false, true, false. So false, false.
True. False.
No. No. Shall we start again? No, you didn't listen to the pattern. Listen to the pattern. Okay, this is the pattern. False, false, true, false. Okay? I'll write it so that people don't forget. False, false, true, false. Okay?
True. False.
What did you say? No. You're a true. Do you get it? Does everyone get it? Okay, we're just repeating the pattern, okay? So, what's the pattern to define odds and even? Exactly. And how many values do we need to define of that pattern? 2, right? Because if we just define 2, so true equals even, false equals odd. So true, false, true, false, true, false, true. That means we're guaranteed, because you're true, that you're going to be an even value in that list. Okay? Does everyone get it? Okay. Dispatches get really powerful, okay? Because we can start testing things. So we can say, what's the average age of this class? 20? Huh? You're older? Who? Okay, so this works really well, okay? If you are under the age of 20, you're true. And if you're over the age of 20, you're false. So if you're over 20, if you're false, put your hand up. How old am I? How old am I? How old am I? So everyone's over the age of 20. Okay. That's fun. But do you get how powerful it can be? So I could say to the architects in the room, if a wall is facing north, put a window on it. And an eave, because we don't want them baking, right? Or if I'm going to get insulting now probably. If a room is a toilet, put tiles on the floor if you're an interior designer. Or if your architect isn't supplying the work in time, yell at them if you're a project architect. Project manager. Okay, so we can define Booleans as true and false. Booleans can also be defined as 0 and 1. Okay? 0 corresponds to false and 1 corresponds to true. So it's a lot easier to type 0 than it is to type true. I've seen so many people try and fail. So if what we're going to do is we're going to write a panel. And let's use the same pattern that we used on the board. Okay? So 1 is even and 0 is odd. And they need to have an enter between them. Just remember that panels, if they have enters in them, those panels treat those items as a single object unless you define something in that panel, and that is defining it as a multi-line object. So you need to right-click the panel and select turn on multi-line data. Turn off multi-line data, and that will create a single item for each new line. So we've now got a list with 1s and 0s. If we plug that into the pattern and we plug our points into the dispatch, we should see nothing change. Nothing should really change, because what the dispatch is doing is actually showing us both lists. It's showing us the true list and the false list. There's something I find really annoying about Grasshopper, and that is that it doesn't really have a uniform way of describing parameters. So I would love A and B to actually be true and false, like T and F or 0 and 1. Yes? Question?
How to create the yellow one to link to?
Pardon?
How to create the
Yellow one?
yeah, the yellow one?
See the little yellow scribble in the params inputs?
Yeah, but they have to show different.
Yeah. So have you got that now?
Yeah.
So now that that's on the canvas, double click it. That'll let you enter data in. Have you done that? And then you can type 0 or 1, enter or return 0. Then you're going to see like a fairly sparse blank panel. You then need to right click that and select multi-line data, and that then makes it a list instead of an object, like a single object with one that text. Are you there now? Pardon? This is something from half an hour ago. Can we go back to that point?
Something's wrong.
You just don't have a point. You need to. Do you have draw a point in Rhino? So draw a point.
So this one.
Yep. Draw it wherever.
Yep.
Right click that. No, right click this. Set one point.
This one. Yeah.
Set one. And then pick that point.
Oh, okay.
Cool? Excellent.
Thank you.
Okay. You should have said that like an hour ago. Okay. So we've made. Do you at least have a panel? Do you have this panel?
Yeah, I do.
Cool. Okay. So we're actually looking at both lists, so nothing's going to change. But what if I plug? So 1 is going to correspond to A, true corresponds to A for a dispatch, and 0 corresponds to, or false corresponds to B. So if we plug our A into our point list now, it will just display the odd values of that original list, and it will create a new list. So these have now their own indexes that correspond to that. Cool? So if we're getting the even values from the first list, if we just copy the dispatch, use the same pattern, and apply that to the second circle, then what points do we want out of the second dispatch?
False.
The false ones. So which output would that be? Yeah. So if we plug our B's in, we see the list corresponding to the odd values. You're a bit lost? Okay, so all I'm doing is, so what dispatch does, have you done the dispatch? Okay, so what the dispatch does is it takes the list and it splits it into two lists, okay? So you could almost call it like an unravel. So it takes your list and all the odd points come out, or all the even points will come out of A, and all the odd points will come out of B. So we can see them now, yeah? Do you see that? So but because they're now their own separate lists, they re-indexed. So they're now indexed 0, 1, 2, 3, right? So if we have an odd number, if we have our all our odd numbers and all our even numbers, and we put them in their own separate list, they now have their corresponding numbers. So that goes from there's 0 and there's 1, 2, and 3. Cool? They're just the numbers on the outside list are going to be 50% between the numbers on the inside list. Cool?
Yeah.
Is everyone happy with the logic that we've got to at this point? Okay, so we could start drawing a 4-point surface, or we could just draw lines. Let's just draw lines first, okay? Because the 4-point surface is going to get a bit confusing to begin with. So where do you think we can get lines? So just go try and find lines. Like draw a line. I'll give you maybe 10 seconds, and then I'll start after 10. Cool. So we can find lines under the curve tab in primitive, and in this case there are actually a few different ways of drawing lines. We just want line, like the simplest form, and we can connect our dispatched even lines with our dispatched odd lines. And you can see that is now, points. And that is now creating a line between their corresponding lists. Now, this is a rather complicated example for the very first Grasshopper user. The reason being that we're already working with lists, okay? So, if I have, I'm so gonna die. I need to stop using this. If I have a point and a second point, we're gonna call this point A and this point B, and we use the line component, A, B, line L. The outcome is going to produce a line, okay? Simple, yeah? The power of Grasshopper is in the fact that we can tell it to do the same thing to multiple items at once. And I think it's almost been inferred through here, and I'm just making it a bit more blatantly obvious. If I have a list of points, 1, 2, 3, 4, and I have a list of points for B, when we plug the list of A and the list of B into this component, it will then recognize that you want to draw 4 lines and not 1, okay? And that's why when I plug 2 lists in, we get 4 lines, okay? So it's doing more work for the same component. Cool? So one cool outcome of this is how long do you think it would take you guys to draw manually? Like you all use AutoCAD or SketchUp or something like that, right? If you draw those lines manually, it might take 2 minutes. Okay, less than 2 minutes, right? But if I were to say, okay, now draw 1,000, it takes a long time, right? Yeah, it's going to take a long time. Then, and this is kind of where I fell in love with Grasshopper, because I would have tutors, because I'm an architect, like I studied architecture, I would turn up to class, I would have spent, maybe 60 hours that week, no, probably not, maybe 20 hours that week working on my assignment, and my tutor would go, maybe we should change this, or maybe we should change that, or maybe we should change this. Am I right? Yeah. And then I would spend the next 20 hours of that week making those changes, and then maybe I'd meet another tutor, or maybe that same tutor would go, no, I kind of want it back where it was. Like, you know what it's like, yeah? And it's frustrating. So the thing is, if I would ask you to draw 1,000 lines, it would take a lot of time. But because we've spent a little bit more time here, I know this class has taken a long time just to get to this point, but the faster you get at this stuff, the more efficient you're going to be at writing these codes, you can say, I want to draw 20 lines, and it took me that much time to do it, okay? So we can chop and change and sculpt the design using this parametric system, and it took very little time whatsoever. To the point where your tutor might say, let's go to 8. Done. Okay? So there was, just to reminisce, there was this one week where I designed a facade for a library, and it was just like, I'd made it quite regular. It was like timber fins, and the tutor was like, oh, maybe we should try like chopping it up and making it a bit more random. And within about three minutes, I'd made it random, and it was something that he was expecting me to like come back next week with. So just be mindful of how quick you can be, depending on the situation. If they just consider that. And project managers, don't expect architects to be this quick. Just saving my ass for later. So let's just go back to 4 or 5. I like 5. 5's a star. Okay, so we know how lists works, okay? Very simply, very, very simply. If you have a list of items, 4 items and another 4 items, if we plug these in as one input and these in as another, each item will correspond. So if I shift these up a bit and I say this is item 0, 1, 2, and 3, and this is item 0, 1, 2, and 3, someone who hasn't said anything in class, I want you to direct me into drawing the line that starts. What's the first line that the computer's going to draw? Have a guess. You've said something in the class. Shh. Yeah. You. Yeah, have a go. 0 to 1. So 0 to 1. Is that what you're saying? Wrong. That's okay though. Do you want to have a go? It's the most simple, just...
1 to 1?
Yeah, that is true, but it's not the first one that it will draw, okay? The first one it's going to draw is 0 to 0, right? Yeah? Then 0 to 1. So what matters? It's not where the points are, it's what index they are, okay? So order matters, and in this case, what can we see here? Where does the 0 point connect to? Right, okay? So, this is a question.
How can I delete any connection between the two?
Pardon?
How can I delete the connection between the two batteries?
The 2 batteries? Let's call them components, okay? You want to, what do you want to do? You want to remove what?
Like the connection between any two, like I make a wrong connection and
Okay, you can right click the output, select disconnect, and then pick the cable that is the wire that's connecting it, like so. Cool? Okay, so second thing about lists, and this is a really important one. Oh, whatever. I've already died. No, you can only buy them in Japan.
I think I'm getting error from this.
Yeah. Huh?
I think I'm getting error from point list.
That is
What's going wrong?
that is because you're plugging a number into the curve, not the curve.
Oh, okay, sorry.
Okay.
So it's this.
So the beauty of Grasshopper is it's visually going to tell you what's connected. Okay.
Yeah.
Okay. So You can also work with lists that are of different lengths. Okay? So a single item is always going to be an item that sits in a list with an index of 0. Okay? When you have items of different length, lists of different lengths working together, then what happens is Grasshopper will go, let's connect 0 and 0. Let's connect 1 and 0. Oh shit, there's no 1. What do? We'll just repeat the last item. Okay? So 0 just gets repeated. So it just steps through and does the same operation with 0 being repeated 4 times. Okay? So if we want to draw the point the line that goes from the center point to 0, we've got a list and we've got a single item, which is also technically a list. So here's our point, and here's our line. We can just create a line that goes from the center point to the inner circle points. And that now is producing 5 lines. So 1 point and 5 points are always going to produce 5 lines. Okay? Pretty simple. Can everyone recognize that we're working with 2 different list lengths? And it's always going to produce the longest list outcome, and it will repeat the last item. So if we had 2 points and 5 points, it would get a bit weird. And in this case, we're just using the fact that the center point needs to connect to all those outer points. Okay? Excellent. So we've created 2 lines. We technically actually have to create 2 more. Okay? So what do we need to do now? We need to connect the 0 point on the outer circle or the inner circle and the previous point. So if I'm looking at this 0 here, what point does that now need to connect to? The 4th point of, or index 4 of the outer circle, okay? So this is where we need to think about lists as circles and not as 2-dimensional lines of items. And we have a component called shift list. And what shift list does is it takes every item in the list and it basically moves it by a number that's defined in that list, okay? So in this case, we just need to take our dispatched even curves and we need to shift our list by a fixed value of -1. So what we'll see is if I plug this now into our point list, right? I'm just gonna, if everyone just watches the screen as I do this, as I plug this in, see how our numbers have shifted in the negative direction? So I'll just do that again. So here's our 0, and after we've shifted our list, it rotates around, it shifts around, okay? Just note the wrap function, the wrap input is set to true. If we set this to false, then it's basically telling this component not to think of the list as a loop and then to think of it as a 2-dimensional line of items, okay? So we don't want the true toggle in there, we just want that set, we don't want the Boolean toggle there, we just want that set to true, okay? We all good? So what can we see now? We can see that this line here could be copied, and now instead of using the dispatch that goes into B, we can use the shifted list to go into B, and that completes our star in a way. Okay?
So can I just see the second line?
Which second line?
The one at the top. What is A? No, the one at the top.
What? This one?
Yes.
That's connected from the center point
Oh, right.
to the first dispatch. So we've got a star. We've made a star shape. And if I ever need to draw a star, I can use this script. We'll get into maybe the more exciting stuff very soon. Don't worry. Like, I understand that it's getting a bit like data managey. You have to think about which point is which. Like, we've got 4 points and one's 0 and one's 1, and we've got a -1 and all of that. But we're going to get something really cool as an outcome very soon, okay? Don't worry too much about this stuff, okay? Because we're going to replace it. Because we're going to replace it now. So, we need to draw 4-point surface. And fortunately, there are 4-point surfaces in Grasshopper, which require 4 points. And it will create a twisted surface if the points are out of the plane. So this is going to be beneficial to us very soon once we make this thing 3D. So there's only going to take a few steps to make this thing 3D, and we're all going to be super excited. Okay, so 4-point surface. We want to think about 4-point surfaces in which direction? So what direction does computers think about, like the standard? Anti-clockwise. So at the moment, we've got, if we think about just one of these diamonds by itself, we've drawn a line that goes from here to here, from here to here, and from here to here. Yeah. Cool? So if we're going to make this anti-clockwise, where are we going to start? Where's a good place to start? Where's a good place to start?
Same spot.
0? 2?
0.
0? You want to start at 0? Okay, let's start at 0. The answer is, it doesn't matter. So it doesn't matter, but let's start at 0. So which point is the extreme one? So when I drew this, were you imagining 0 is the outer one or the inner one? You don't know? Doesn't matter? Let's say it's the outer one, okay? So I'm going to grab a point parameter, and let's assume that, I've jumbled up. I'm not really sure where I am anymore. And what we're going to do is plug our dispatch cable, our first one, into point. Therefore, actually, let's now just hide. What I'm doing is hiding everything. So I'm going to go Control A to select everything. I'm going to right-click or middle-click in the canvas, select the blindfold, disable. Then I'm going to select my lines, middle-click or right-click, and then select Enable Preview. And then I'm also going to enable the preview of this point that I've just created. So, are these points going to be our starting point? No, we want it to be the outer point. So what we'll do is we'll then try the next one. Is this the outer point? Yes. Okay. This is going to be our first point in our 4-point surface. Cool. So we'll plug that in. Then our second point is going to be anti-clockwise to that. That's going to be this point here, which is our dispatched point from the very first dispatch. So here it is going into a new point parameter. Is everyone following? I'll slow down. Everyone good?
I've done something wrong. Lost.
Where are you lost?
Do
Do you have this?
Not yet, no.
Okay, let's grab the 4-point surface. You can grab it here.
I've done the start, but I've just missed the
This one?
connections from the point to the.
You've missed these.
Yeah. One.
Don't actually worry about, like, we're not going to use them, okay? Cool? Let's focus on this. So we've got our point and our 4-point surface, and we've plugged our point from the second dispatch into a point parameter. I'm just using these point parameters to organize, okay? And preview. So that's going to go into A. Then I need another point parameter that's going from our first dispatch, and that's going to go into B. So what that's doing is it's coming down here, and then what's the third point going to be? If I'm going anti-clockwise, where am I going? Center point? Okay, so let's go, let's get a point parameter and plug that in, our center point into that. And then we're going to bring that in. And what I'm going to do, just so that, because it's a bit off the screen, I'm just going to right click my point, my third one, and I'm going to call that, change the name of the top, in the top section, and call that CTRPT for center point. I'm then also going to right click it and select the little paint bucket, which will then change it to actually say the name of the parameter. And what I'll do is I'll also do that for my other one. So I'm going to go outer PT. Whee. Oh, drat. I've stuffed that one up big time, haven't I? Okay, I made a mistake, but that's fine. We'll fix it. Okay, so we've got our center point, and we'll connect that. And if we now preview our 4-point surface, we should start to see a triangle appearing for each of the pinwheels. So the thing that I stuffed up, when we created these lines, what I did was I shifted the list so that these points on the outer circle are shifting, right? But for us to finish our diamond, we actually need the inner circle to be shifted, not the outer circle. Because I need this last point to finish the diamond off. And what does that belong to? Right. And is that, if this is item 0, if this is 0, 0, and 0, and this is item 1, then we need to shift the inner list, not the outer list. So what we're going to do is we're going to plug our dispatch into our shift list. We are going to change the number -1 to 1. My apologies, I made a mistake. Sorry, guys. And then we are going to we're going to create one last point parameter. We're going to call this inner shift. I'm going to plug my shifted list into that, and I'm going to plug the output of the inner shift into D, which will then complete our diamond.
Did you make a new shift list one or?
No, I used the old one. Call these parameters whatever you want. You can. I find there are these things called scribbles, like this. You can get them here to use to like comment your script, but I hate them. They're terrible because they disappear like at a certain zoom, and so like if you want to select a script and move it, it doesn't necessarily select them, and they just get in the way. What I prefer is doing this, so like grabbing parameters, right-clicking them and naming them, because then what that does is if you use the middle click and see the little find, like the magnifying glass, if you then type outer, it actually will find those parameters for you instead of you having to visually find them. So it's just a little tip for me. Okay, so we don't need these lines anymore. They were just there as a guide, so let's delete them. And we'll just leave these point lists here because they're useful sometimes. So what this has done is it's created 4-point surfaces in 2D. If I go in and start playing with my parameter, I can change the number of segments. I can play with the radius, the inner radius, and the outer radius. And the outer radius will always be larger than the inner radius. Cool? We have everything we need here to create the stars on the Australian flag. So, we've got an hour. Okay, we've got to speed up a little bit. We need to go 3D. We need to be 3D, okay? So what would you, we're actually done. We've finished this pseudocode. Ta-da! Ooh, which way am I going? We have the pseudocode that I rubbed out, we've finished it, okay? Do you remember the pseudocode? Okay. So, we've done it in 2D. There is only really one step or two steps that we need to take to make this 3D. And that is by picking some of these points and moving them upwards, okay? So this is where we get into using some transforms, okay? So one transform, really simple one, is move, okay? So move just basically moves an object. Doesn't rotate it, doesn't scale it, just moves it, okay? But what instructions do you use to someone to move something? Like if you were to ask me to move this mouse, how do you tell me how to move it? From point to point, okay? So to find the point, so this is one point, and where's the other point? Just pick one. Say corner of the, let's say corner of the laptop, right? That is a line, but in other terms, we could also describe that as a vector. Who did Year 12 physics, Year 11 physics, Year 10 physics? Only one person? Do you know what? Do you know how common that is in the design industry? Most people didn't do physics in high school. I did. Okay. What about maths? Who's familiar with what a vector is, apart from you? No one? Okay. Vectors are... A vector is an object that describes direction and length or amplitude, okay? So when I say go north, that is only 1/2 of what a vector is. A vector is north and 10 meters, okay? So we can move things with vectors, because vectors effectively describe movement. They can also describe other things like velocity and momentum, blah, 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 blah. So, yes?
I've done something correct there. It's like, I think it's too much.
You've done something incorrect?
Yeah.
Okay.
Yeah, so shift.
Ooh, just set that integer to, I think, 1 instead of -1.
I can't really make stuff. I don't know what's going on. I don't know.
You need a 4-point surface. Okay, guys, who doesn't have 4-point surface? Who didn't get to that point? Just you? So go grab a 4-point surface. You can find them here. Did yours work? Did my suggestion work? Then, just hang on, just one sec. Just to double check, is everyone now shifting their first dispatch, not their second dispatch? What's your name, by the way?
Woody.
Woody, okay. Is there any buzz in the room? No? Okay. So I really don't want to go and fix it. So I just wanted to double check. So have you got your 4-point surface?
Yeah.
Okay, so you should have 2 dispatches,
Yeah.
a shifted list,
Yeah.
and a center point over here.
Yeah.
Right. So that's all you need to create the 4-point surface. Yeah? Just double check, is your dispatch, the first one, connected to the shift list? Is your first dispatch, this one here? No. Well then, can you connect it? Can you just double check yours is doing that too? Oh, we got 1 hour. 1 hour. We can do it. We can do it. I got a shortcut. Yeah, shortcuts. Is everyone kind of understanding? Like, I know this has been a really harsh icebreaker into Grasshopper, but you getting it? It's making some sense.
I just really hate how messy it is.
Oh, that's just me. You can.
I mean, I try to keep it neat, but it's like impossible.
Okay, I get it. I think I just gave in to that when I got into it. Like, I was like, you should see my scripts are atrocious.
We try to find specific parts.
You, huh?
Even just going back to trying to find which dispatch was hard, and there's like barely anything.
Well, okay, so there's a few things that you can do. You can label dispatches, so we could actually click this one and go type first dispatch. But then you have to basically turn that into text for it to, and that's ugly, in my opinion. But you can put things in groups. So you can, I've just hit Control G after selecting that. This is now purple. We can right click the, if we right click the group, that we can now say first dispatch. And that might help. Are these little things that can help you? Cool.
There's
Okay.
like little alignments as well that you can
Yeah.
use with it. That's what I've been doing, trying to get it done.
Let me just quickly find a script, just to demonstrate how poorly. This isn't so bad, but actually, no, I'll show you later. I'll show you another week so I don't scare the hell out of you before census date. Okay, so so you've got these 1, 2, 3, right?
Yeah.
Okay, now, so is your first dispatch, you can see, is there a green connection to your shift list?
Yeah.
Yeah, and is your shift list set to 1 or -1?
1 at night.
Excellent. Is there any way for me to set this as a default? Font. No, there is not. Okay, I'll work that one out later. Okay, so then what we need to do is just set out these 4 points. So the outer points, the inner points, the center point, and the inner shift need to connect to the 4-point surface in this order. It's really important that they're in this order. Outer point A, inner point B, center point C, inner shift D. Is that working for you now? It's working?
Yeah, I agree.
Huh?
Yeah.
You're getting a star now?
Yeah.
Is it working for you? No. Okay.
How do I go out of point?
Huh?
How do I select the point?
Outer point, I wrote that.
Oh, you wrote that?
That's a
Okay.
point parameter that I've written. So just type point.
Point.
Yeah.
Just going.
Yep, click that one. Yep. Right click it and see. And I've written that there. Cool. I'm just going to move forward, okay? Because we've got, this is being recorded. Yes.
Yeah.
You're still what? Then change it to 1. You're in control of your script. Don't let it control you. No, it won't. No, there's no way. No, that's not true. If that's true, your grasshoppers become sentient. And close it down now before it takes over the world. Okay, so we're just going to move forward. So it's being recorded, so no worry. And I've got work after this, so I'll process it while I'm at work. But don't tell my boss. So we need to make this 3D. And this is one of the beautiful things about Grasshopper. Because it is effectively a map of the steps that you're taking, every step that you take is turned into a component, okay? We can actually go back and change the process. We can go in and add raisins to the mix, yeah? So what we're gonna do is we're gonna take our outer circle, which is defining the outer points, and we're gonna move it using a vector. So the vector we're gonna use is just gonna be up. So for those of you who aren't familiar with Cartesian coordinates, especially in Rhino, up is represented by Z, okay? So we can think of east, west as X, north, south as Y, and away and towards Earth as Z, unless you're a flat earther, then you shouldn't be at uni. So what we're going to do under vector is we're going to just go grab the unit Z. What that does is it produces a Z vector off a number. Let's copy one of these number sliders and we're going to plug it into the F of this unit Z. So we've created a unit Z. We can get unit Z here. Oh. All good? Cool. Then we want to transform our circle. So we're going to use go to transform, and in transform, we're going to use the Euclidean transform move. For those of you who are curious, Euclid was a mathematician. he defined a lot of what we would consider simple geometric transformations, like move, rotations, hence why we see all of his computations appearing in the Euclidean geometries. He's very important man. I think he's the only man who's got his name actually in, oh no, there's a few others. People get their names in. There's Delaney, he's got his name in. He's a very famous mathematician. I might show you some of his stuff later. Okay, so we've got move. Move takes geometry, so this circle, we're going to move the circle using this z vector. And you can see now as I slide this up and down, our circle moves up and down. So what we're going to do is we're going to replace the 2D circle the one that's on the ground plane with the one that we've moved. So if we plug our moved circle into the divide curve, this second one, not this one, but this one, if we plug that in instead, what that does is it redefines the whole script to use that second circle for those points. So now, as I move that circle up and down, we begin to move our object in 3D. And so it might be a bit more attractive if I reduce this to something like 6. Okay, and then one more thing. It's really hard to live or be in a pavilion that's literally got no height to its center. We need headroom, right? So we're going to also move our center point, okay? But we're only going to move this center point as it plugs into our center point over here for the 4-point surface, okay? So as we do that, that then creates this 3D object. So what I've done is I've moved the circle. So these two are moving and I'm plugging them into the divide curve. And then I'm also grabbing the center point and moving that up using the exact same vector, plugging that into the center point parameter that's going into the 4-point surface. And we now have a parametric hyperbolic paraboloid pavilion. I'm getting this really like this concerned face. Are you concerned? So how did you do that? Yeah.
Just repeat slowly.
Repeat slowly? Okay. What I've done is I'll undo everything. I'll undo it, okay? Not everything. So I've got a slider with a Z, unit Z, and I'm plugging that into move. And what move does will move an object using that vector. I'm then going to take the second circle, the outer circle. So I'll preview the inner one as well, so you can see it. So I'm going to take the outer circle, and we're going to plug that into the move. So you can see that we've now got that outer circle that's been moved up. Has everyone got that? Excellent. Okay, so we can see that this outer circle is plugged into the divide curve. What we need to do is replace that. So all we have to do is say, take the output of the move, drag that onto the input of the divide curve, and as long as we're not holding shift, it's going to replace that cable, and we are now using the moved curve as the outer curve that generates those points, okay? Does that make sense? Excellent. So, because we're getting a rather flat object right now, we can either, actually I'm going to throw in a little extra, we can copy this whole section, copy it and we'll move it to the top of the script. And what we're going to do is use this same process to move the center point. So you see this center point, we've now moved that. And we can now also move it independent of the outer circle. And we just need to use this point for the 4-point surface. So we're going to plug this move into center point, giving us control over our 3D object. Cool? Excellent. Less concern? Excellent. Okay, so we're not done. I wish we were, but we're not. Now, we need to make this planar, okay? When we build things in real life, usually we want to make them out of planar objects because it's easier to manufacture them. So in this case, we need to start dividing this down into triangles to make them planar. Okay, so we're going to truncate each panel into 4 triangles. And the easiest way I can do this to save us maybe half an hour of explaining things is we just need to get the center point of our surface. And I'm not going to explain it too deeply right now. We're going to get into what parameters are further into the semester. But if we take our 4-point surface and we use a component called evaluate surface, what this component does is basically you ask it to pick a parameter on a surface. It'll give you the point, the normal, the U direction, the V direction, and the plane that is defined at that point on the surface. We don't need to worry about most of those things. We really only want the point. And what we're going to do, oh shit. Crap. I've just made this more complicated for you guys than what you need it to be. Okay, forget that. Forget the evaluate surface. Gone. Just thinking on my feet. Playing it by ear. Okay, what we need to do, what we're going to do, just to explain it before we do it, is we're going to draw a line that runs along the surface that goes from the midpoint to the outer point. Okay? It's from that line that we're going to pick a point on that line. So let's say that point is here. And we're going to use that point to draw triangles to the edges. So we're going to create a triangle like so, a triangle like so, and a triangle like so. Okay? Therefore, triangles are always planar, making a planar version of what we've just created. Okay? Are you guys expected to create a 3D model for this? I think you are. I think you have to 3D print this. We'll get you there. We'll get you to 3D printing it. Okay. So, what we need to do is create a line that follows the surface. Normally, I could just give you this point and we draw a line. But if we draw a straight line between these 2 points, it's not going to follow the surface. Okay? So, fortunately, there are ways of drawing lines between 2 points on a surface. And that, by doing so, you need to use this thing called Geodesic. You don't actually use it, you won't be using it that much. I barely use it. It's a very weird component to need. What it does is it takes a surface as its input. It takes a starting point. So our starting point will be our center point, and an endpoint. So the endpoint will be our outer point, and it draws a geodesic line along the surface to connect those 2 points. you'll find geodesic under curve in spline. We are almost there. We might actually have maybe 30 minutes of like working out, like solving problems, which is good. Okay. Those of you haven't been using a computer, have you been following along at least? Have you been making sense? Okay, good. Okay, so we need to pick a point along these curves, and we can do so by analyzing the curve. So under analysis in curve, we want to use evaluate curve. And if we plug our curve in and we plug a number into that, the t value, the parameter value, you'll probably notice that barely anything happens, okay? So as I slide this up and down from 0 to 1. If I zoom into this top, can you see as I slide this up and down, it's only moving a short distance. It's only moving 1 millimeter, basically. So there are two ways that we can evaluate curves. We can evaluate them using their actual dimension, or we can reparameterize them. What reparameterize does is it makes the computer think of the line as a number between 0 and 1, or 0 and 100%. So using percentages, where do you think the midpoint of a line would be? 50%, okay? So what reparameterize does is if you right-click the C value, the C input for evaluate curve, does everyone have evaluate curve? Woody, do you have evaluate curve? Okay, that's fine. That's all good. If you right-click the C value and go reparameterize, we now have a number that goes from 0 to 1 and goes from 0% to 100% along that curve. So it doesn't matter how long the curve is, as long as we use 0 to 1, we can pick a point along it. Okay? Yes?
Mine only goes from 0 to 1 and doesn't stop it.
So, huh?
My slider doesn't stop in the middle or anything.
It doesn't stop in the middle?
No, it just clicks into 1 or 0.
Oh, is that because you double-clicked and typed 1? Okay, if you double-click and type 0.00, that'll create a number slider that is with 2 decimal points.
Cool.
Cool? Okay, so what we're going to do is double-click the slider and type 0.5 just to make it set at the midpoint. But you guys can decide to do that to any any point. So that's now at the midpoint. I realize you guys will understand why we're doing this once we get there. We're also going to grab the curve parameter. I know we've told you guys that parameters are just there to store things like a shelf, like organize things, and they don't really do much, but they do. They actually have little functions in them that they do due to the geometry. And the cool thing about curve is if you plug a surface into curve, what it does is it will give you the boundary curve of that surface. So we've got a curve and we've got a point. And there is a function that we can use that creates pyramids. If I had a square and a point, I can use that function to make a pyramid, okay? That square doesn't necessarily have to be a 2D shape that sits on a flat plane. It could be a 3D shape. So the function is extrude point. What it does is it takes a curve or a surface and it extrudes all of the faces or edges to a point. So if I plug my outer boundary curve and my midpoint, it will create a truncated pyramid that goes to that midpoint. So now if I hide everything but this particular component, we now have a truncated planar geometry of the shape.
Can you zoom out a little bit? Because I've just
Sure. It's just, yeah, it's... So we're using the outer point and the center point for the geodesic. We've gone through so much. This course is kind of like inverted. It starts off super hard and it gets easier.
How do you change the number size from 1% to 100%?
0 to 1.
Just 0 1 instead.
Yeah, so if you want to, is your number slider just going from 0 and 1? It doesn't do anything in between?
Yeah.
Then when you create a number slider by double clicking, type 0.00 instead of just 1 or 0. Because by adding more decimal places, it'll add decimal places to the number slider, giving you more resolution as you slide up and down. So have a look. When you create number sliders, you can double click. When you double click, type 0.000. That will create a number slider that has decimal points. Otherwise, if you already have a number slider, you can double click the name of the slider and then you can add decimal points in the dialog, but just make sure that the number, the rounding number is R instead of N. So it's a real number instead of a natural number or an integer. And so as I slide that up and down, that changes where the point is on the surface, which then defines where that will be for that truncation. Yes.
I'm not sure which part.
So your geodesic requires the 4-point surface to go into the surface.
Yeah.
Then you've got, oh no, that's your computer. And then you're going from your center point to your outer. Perfect. So you just missed that one.
Is still this difference also. And that's the part where you connect the points.
Okay, so then you've evaluated, and this really should be like a floating number. So you can slide it between 0 and 1, so see how that's moving. And then you've got your outer curve and your point. So we just need to use the extrude point component, which is this one. So plugging our curve into that and our point into that, we've now generated that see that sort of like planar thing. So then if we just select everything and hide it, select the extrusion. Cool? Excellent. Excellent. Yes. Okay, I'll show everyone the very last steps and then I'll help you out, okay? Okay, we're going to do 2 more steps and then we're done. Then I'll come around and fix everyone, except for maybe Woody.
Yeah, I think I'm ready.
Okay, so last steps. We need to 3D print this. 3D printing requires objects to be, yes?
We actually don't 3D print this on this chat.
What do you have to do? Nothing.
Nothing for this week. Next week, I think we laser cut.
Do you want to do you want to take the steps to make it 3D printable?
Yes. Sure.
Okay, let's do it. This guy wants to print this. He's like,
Where do you find under which tab?
the params tab. It's here. You can find it here. Okay, so last but not least is making this solid. All we have to do is use a process of extrusion. When you extrude objects, if you extrude a curve, it'll produce like an open surface outcome. If you extrude a surface, it produces a solid outcome that can then be 3D printed or Booleaned or whatever. But right now we've got 4 surfaces or 20 or whatever that are all separate, and we need to join them as one object before we extrude. So this is kind of like a crash course. So I'm going to explain how joining works in the future a bit more. But if you go to the Surface tab, under Utility, there is a BREP join component. If you plug your Extrude Point surfaces into the BREP join, then what that will do is it will compact them all, join them all, four or however many surfaces or BREP, open BREPs, into one single BREP because it's now joined. So it's gone from 4 or however many to 1 because it's joining them. So it's a single object now. Still getting confused face. Do you get it? You don't get it. Which one? Extrude point, BREP join, or extrude? The panels. I'm just using the panels to look at the data. So you can get panels here. It's that little yellow scribble. And when you plug things into panels, it shows you the information that's in them. So the output of this extrude point are these 4 objects. And the output after you run the BREP join is one single object. What that's doing is it's not getting rid of these 3. What it's doing is it's joining these 4 items into one single item. Okay, that's basically what it's doing. Then if we plug that into the extrude, and what we can do is just go grab one of these unit Zs from before. So just a number slider and the unit Z. And if we zoom over here and paste center, so Control-Shift-V, that'll conveniently place those where we need them. Plug that into the D value. That will then give you a height to your BREP. So we've now got a solid shape, and this is basically when we bake, right? So if we wanted to 3D print this, we then select this extrude geometry, middle click or right click, select the egg, and then if we quit Grasshopper, there's a solid geometry that we can export to STL to 3D print, or we can render it. Like you can use it for your presentations, whatever. I'm guessing we're going to see a lot of these in people's studios, maybe. Who knows? Especially because your tutors are going to look at this and be like, hang on. It's so detailed. There's just so much stuff. Yeah, so obviously you guys are designers more than coders, so feel free to pick something that's attractive. But yeah, that's how you do it. So yeah, you just need to join and extrude with a vector. Cool? So I'm just going to put this back to something a bit more attractive. I'm going to maximize it, and I'm going to dash around and help people get to this last point. We all good? I'm going to stop recording.
How do you save? Is it just normal save?
Yeah, just save the script. So file, save. It's separate to the file that you've got open. The Rhino one. Are we all good for recording? Like I'm going to stop recording and just help people? Cool. Stop.